All right, here we go. This is Unit 9, Lesson 5. It jumps from Lesson 2 to Lesson 5, but it's all the same stuff. So what we've talked about in the last couple lessons is we introduced ourselves to the arithmetic sequence. And so what that is when you add or subtract to get to the next number, to the next number, to the next number. The two formulas that we kind of figured out. Okay, so we begin with a common difference. And the simplistic way of getting that is A2 minus A1. And then also, you obviously probably want to know what A1 is. All right, the very first element. All right. So again, that is the letter, excuse me, yeah, that is the letter N. 1 is N, and so you can plug it in. All right, then we talked about the explicit formula. And the explicit formula allows you to jump to whatever number that you want. That's AN, and the adjustment was DN plus A1 minus D. So if you have that difference and the first number, you're good to go, and you're able to jump to whatever number that you want. All right, so that's kind of where we're sitting as far as the arithmetic, arithmetic, easy for you to say, sequences go. And then we talked about the geometric, which is just multiplying, in essence, to get to the next number, to the next number, to the next number. And similarly to the arithmetic, we have to know, obviously, not a common difference, but a common ratio. And again, the simplistic way of doing that is A2 divided by A1. That oftentimes gets you what you want. You also probably want to know A1, the first number, and then its explicit formula, the one that allows you to jump to, you know, the 52nd term or whatever you want, is AN is equal to A1 R in a parentheses to the N minus 1 power. Again, you just plug in whatever you want for that N, and you are off and running. Okay, that's where we're at. What I think this assignment has to deal with, I didn't really take a big time look forward, is I believe we're getting into summations. So if you look over at the formula sheet, it's these bottom formulas right down here. All right, and we'll absolutely, obviously, talk about those things. All right, so let's go ahead and get into this one. Okay, number one, what is the common difference? All right, so the common difference would be A2 minus A1. So in this case, that would be -8 minus -12, which is a +4. All right, so let me not write as much. -8 minus -12, which is +4. All right, there we go. We probably also need to know what is A1, common difference. A1 is the first term. And then our explicit formula would be the difference times N, and then -12 minus 4. That's the explicit formula. And then we are asked to find the 12th term. And so now that's just easy calculator work right now. All right, so our common difference was 4, and the 12th term was 32. Okay, similar problem. All right, so the common difference in this case is 5 over 2 minus 3. Negative 1/2. Okay, A1 is 3, making AN equal to the difference, N, and then 3 minus 3 minus negative 1/2. 3 minus negative 1/2 is 7 over 2. So positive 7 over 2. What is the ninth number? So here's how I need to use parentheses. I need to be very conscientious about this. So the ninth number plus 7 over 2. Negative 1. There you go. All right, so our common difference was negative 1/2, and the ninth number should be negative 1. Okay, now we're going to get into the summation. Okay, this next problem is getting into the summation. What a summation is, okay, it says find the sum, okay, of the first 50 terms. All right, so here we have 1, 2, 3, 4 terms. Now, if I were to take the quote-unquote sum of those, or the summation, that would be those numbers added up. So for instance, negative 6 plus negative 2 plus 2 plus 6, and then so on and so forth. And what this is going to do is it's going to ask us to add up the first 50 numbers. Now, that would be ridiculous to write down all 50 numbers and then add them up. Luckily for us, there's a formula to help us do this. And this is in essence the sum. Okay, that's what this like sigma thingamajabber is. All right, so the sum of 1 over 2, so 1/2 n, a1 plus an. All right, so kind of breaking this down is this. N is the number of terms. So in this case, that is literally the number 50. A1 is the very first number, which is negative 6. AN, or AKA A50, is the 50th number. And right now, we don't know what that is. But if we do the process, just kind of how we've been doing right there, we first have to figure out that last number, and then we can go ahead and add them up. And so this is the formula for our summation. So what I need to do to make this clock tick is first figure out what is the very, very last number of this sequence. So I'm going to put this aside, and I'm going to figure out that very, very last number. All right, so our difference in this case is negative 2 minus negative 6. So that's positive 4. A1 in this situation is negative 6. AN is BN, negative 6 minus 4, negative 10. And then I'm after the 50th number. And that should be, what, 190, I think? Okay, 190. All right. So now I have all of the bits and pieces that is going to make this summation formula work. Okay, and we are going to find the first sum of the first 50 numbers. All right, so this is equal to 1/2. N is the number of terms, so that's 50. A1 is the very first number, that's negative 6, plus AN is the very last number, which we just found to be 190. And if I just literally plug that in, I'm good to go. So if you were to add the first 50 numbers of this set up, that would be 160. All right, next problem, same type of problem, just different numbers. All right, so the difference that we're looking at here is 1.45 minus 1.50. Negative 0.05. The first number in this situation is 1.50. That makes our explicit formula b, n, and then 1.50 minus negative, so that would be positive 1.55. 1.55. And then we are looking for the 20th term, or 20 terms. So the 20th term, b, .55. So that's the 20th term. I may have gotten that wrong on the answer key. I'm not sure. All right, so let's find the sum of the first 20 numbers. So the sum is 1/2 n a1 plus an. So the first number plus the last number. So that's going to be 1/2. I'm looking at 20 numbers. The first number plus the last number. Okay, now notice in this problem they don't define what type of sequence that is. Is this arithmetic or is this geometric? I'm assuming it's arithmetic, but I don't know. They just define it as sequence. So what I need to do is I need to define, is it a arithmetic or is it a geometric? So I see that the difference in this situation would be 20 minus 8, or the ratio in this situation would be 20 divided by 8. All right, so it's either I'm adding 12 or multiplying by 5/2. And looking at these last ones, I see that it is indeed adding 12. So this is indeed arithmetic, not geometric. This is indeed arithmetic. Okay. So continuing on with that line of thinking, I see that A1 is 8, AN would be 12N, 8 minus 12 is -4. I'm looking for the sum of the 10th term, so I need to find this last number. So 120 minus 4 is 116. So the sum of those, so the sum is 1/2 n first number plus last number. This is going to be 1/2 of 10 terms, first number plus last number. All right, so again, they don't define the sequence. I see that it's arithmetic, but in case you don't, is this. So it's 37 minus 40. So the difference is going to be -3, or the ratio is going to be 37 divided by 40, which I think is that. So it's either in subtracting 3 or in multiplying by 37 over 40. And again, with these last ones, I see that it's -3, -3, -3. So again, this is arithmetic. So I'm going to follow the arithmetic, not the geometric. So A1 is 40, AN is B, 40 minus -3, so that's positive 43, and I'm looking for the 10th term. So that's -30 plus 43, that's positive 13. So the sum in this situation, 1/2 and first number plus last number. All right, this question is asking us to find the sum of the first 42 terms within an arithmetic sequence. All right, so again, they straight up give us the difference. They give us the first number. So what we have to do is we have to find the last number. And so that would be D, N, and then 13 minus -4, so that's positive 17. And now I'm looking for the 42nd term. Okay, so to find the sum, I need to take 1/2 and first number plus last number. So that's 1/2 of 42 terms, first number plus last number, so it's plus -151, or aka minus 151. Okay, I bet the next lesson is probably the geometric idea of this, the exact same thing. All right, so the sum of the first 20 terms, arithmetic. Okay, so again, just this same as last time. So the difference is 3, and the first number is 5. So that's the difference, and this is 5 minus 3, which is a positive 2. We are looking for the 20 term, so I need to know this last term, which is going to be the 20th term. So that's 60 plus 2. Okay, the first 4 terms, sum of the first 4 terms, arithmetic. 25 minus 10. I'm looking for the fourth term. So 40 plus 15. That's the sum. All right, and in this particular question, because we're only talking about 4 terms, we can actually probably just check this, just to, you guys kind of been going on blind faith that this thing works. All right, so if the first term is 25 and the difference is 10, that means the second term would be 35 and then 45 and then 55. So these are literally the first 4 terms. So if you want to double check to make sure that these formulas work, we can literally easily find the sum of the first 4 terms. So 25 plus 35, 25 plus 35 plus 45 plus 55. Boom, 160. So the formula is working. The sum of the first 4 terms is indeed 160. Okay, the sum of the first 32 terms. All right, so the difference is -2. The first number is 10. AN is the difference. N, A1 minus D, so that's 10 minus -2, so that's a positive 12. And I need to know what is the 32nd number. Okay, so the sum of 32 terms is the first number plus the last number. There it is.